The idea of Pyrex was cooked up by the wife of a glass industry scientist in 1913. She believed the tough glass used in lantern globes would be great for baking cakes in. So, she baked one in some glass her husband brought home. The cake was a hit, and the notion that glass was too fragile for the oven was shattered. Today, you'll find glass cookware of various shapes in most homes. A true recipe for success. A batch feeder pushes ingredients into a large furnace as they spill out of a bin overhead. Silica sand is the main ingredient of the mix. It's a crystalline substance which makes glass transparent. The batch also includes soda ash and recycled glass. Some of the other ingredients are a trade secret. The furnace heats the mix to its melting point, over 1,500 degrees Celsius. It turns into molten glass. The glass in this lava-like form will spend up to 24 hours in the furnace. On its way out, mechanical shears cut it into gobs. The gobs slide down a water-cooled chute and drop into a baking dish-shaped mould. There are 16 moulds on a rotating table. As it turns, the table delivers the gob-filled moulds to a plunger, which presses them into the baking dish shape. Continuing to rotate, the table positions the moulds under blowers. They cool the freshly moulded glass so it holds its shape. A mechanical arm suctions up the glass dish and sets it down on another revolving table. Flames lick the glassware from burners above and below. The dish is exposed to a temperature of over 1,000 degrees Celsius. This softens its sharp edges so that the rim is smooth. Next, hoses blast high-pressure air, cooling the dishes to solidify them so that a mechanical arm can pick them up without misshaping them. It transports the glass dishes to a conveyor belt. Further down, another arm feeds the dishes to a kiln, where heating and cooling cycles temper the glass. This is what gives the toughened glass its strength. Now it's time to put a lid on things. A different plunger presses glass gobs into a lid shape. Every good lid should have a knob. So, a valve inside the mould forms one, and then thrusts the lid upwards to be picked up by a mechanical arm. The arm flips its lid and sets it down on a conveyor belt. The lids are on the move, travelling through a tempering kiln. On their way out, a fan cools them off so they can be handled, this time by human hands. Each glass lid is inspected before it's packaged. On another line, there's a product that's made to measure. Small platforms lift the measuring cups to suctioning arms that protrude from a revolving silkscreen machine. A squeegee forces enamel through a screen, printing measurements onto the cup. Over in the lab, this sample dish is being roughed up. Rubbing it with sandpaper mimics years of wear and tear, but it's about to be subjected to even more abuse. A sharp tool is placed in the center of the dish before it's time for the hammer test. Will it break without shattering into numerous little shards? It's a clean break, which means this dish has met the quality standards. Smashing. Or to put it another way, this glass has plenty of class.